My name is Almodóvar. I'm the co-founder and chief scientific officer of Ergosuture Holding Corporation, and also the inventor of the drivable technology. And today we're going to talk about a surgeon's perspective for medical device development. Having all these enriching talks before, has definitely enriched my thought process on this too. So, first things we're going to say is that for us surgeons, this is a change of pace. When we are doing surgery, we're doing something that is fast-paced, something that has an immediate effect. But when we're doing development, you need to change that mindset. And this is where all this magic starts coming through, because it's a longer lead time, a much greater impact, but it requires you to make sure that you're in for a marathon. And one of the main challenges when you're doing development is to really hone down what is it that you're trying to do. And that means identifying what is the unmet need. And that's because the surgeries, the surgical act entails multiple multiple things happen at the same time, multiple simultaneous processes. And you must manage concurrent environmental factors that affect one another. So you must recognize what works and leave it like that. You don't want to change the entire picture. So you want to just recognize what specific thing you want to improve and how. So when we're doing all of that, we need to look for opportunities in which to specifically intervene to identify what is it that you need to do. And okay, beautiful. So we have it.
Yes, I'm navigating it for you.
Oh, beautiful.
Yeah, so just let me know when you want me to move forward.
Okay.
Oh, you also started as well. Awesome.
Okay, beautiful. Yeah. For some reason it didn't go through, but yeah, basically. Okay. So so we are identifying specific things that you would like to improve, and you need to integrate those specific things into the process. And you need to do that because you need to preserve precisely what works, substitute what doesn't work for this new procedural or technological improvement. I need to do that in a way that allows you to move on with an improved process without sacrificing all the present capabilities that you have. So you don't need to start from a blank page every time that you invent something new. Okay, and let's see if I'm trying to navigate here, but for some reason, you can, next slide, please.
It's on your screen. If you hit the arrow, hit the right arrow, it should take you to the next one.
Okay, beautiful. Okay. So when you evolve the technology, you also evolve the challenges. And in suturing, that is very important, and that's definitely something that we have to take into consideration. So when we have now advanced suturing devices and technologies, especially during laparoscopy, that also means that you need to adapt and you need to learn to master those devices. Sometimes those devices are not as familiar, and you need to advance also the surgical techniques which are not familiar. So you want to also try to, while advancing that technological feat of trying to do suturing better, you want to keep that familiarity and use platforms that can be very versatile and can be used across surgical platforms, technology that you can use, in any surgical scenario. Inherent to that, there's one thing that we have identified that is crucial, and that is that predominantly the end users, like the surgeons in this case, are predominantly intervening in the development process at the level of the voice of customer, which means that their input is being taken, but then all that task analysis and everything is being done along all these processes that you see right there. Okay? And what we would like to do is make sure that we integrate that customer more in that development process. If you see right here, you see on the left side, you see a huge list of tasks, analyzing step by step, in this case, what the suturing process is. And let me just go directly to line 14, which it says, hold the needle with a needle driver. Well, that seems very simple enough. And from the outsiders and the observer's point of view, this is just a step that needs to be taken. But what happens is that if you ask the surgeon, the surgeons will tell you that, particularly in laparoscopic surgery, holding the needle with a needle driver might entail repeating that step 2 or 3 times. It might mean having the needle being taken, more to the front of the needle, to the back of the needle, near the tip in a certain orientation. And that highlights why all these nuances in this process need to be taken into consideration from the surgeon's point of view, so you can polish that process and create a very clinically relevant, coherent solution to the problem at hand, in this case, laparoscopic suturing. Okay, and laparoscopic suturing is still tedious, and it's still tedious because you have to go through the ports and you have to basically have a counterintuitive motion of the instruments, and that while standard laparoscopy has all the advantages in the world in terms of saving time, having the patients recover well, particularly in this time. We want patients, to spend the least amount of time and resources in the hospital. You have technologies like the endo-stitch and the seal stitch that present some benefits, but that also present some challenges because this is an unfamiliar technology. You have to train yourself, and the technique that you use is limited to the device. It's something that you have to learn, particularly with that, but you cannot extrapolate anywhere else. Robotic-assisted surgery definitely has a lot of promise, a lot of degrees of freedom, but is prohibitively expensive in many regards, and also requires a learning curve that is not insignificant, and it's rather long to adopt. So the core message here is that advanced suturing does not necessarily mean simpler suturing. Advanced suturing means that you have a lot of capabilities that you want to put in the device. It means that you want to focus maybe on the knot tying or the articulation or all these bells and whistles. But also that means that you depart from the muscle memory, the training that the surgeon has. And that's important because that also relates to how easy these technologies can be used by the end users. But you have a whole host of other benefits by trying to leverage all that surgical knowledge and surgical training that you already have, all that muscle memory that you have already received in your training, to take advantage of the traditional needle drivers and the simplicity of how they function to deal with suturing scenarios in laparoscopic surgery. And you can use that not only in laparoscopic surgery, but in many other scenarios as well. And that highlights that the suturing process could be more efficient because, of course, the focus of the advanced suturing devices is to try to make those processes more efficient, but at the expense of having that familiarity taken away. So you want that middle ground because many of the steps in the suturing process are multidimensional steps. When we were highlighting that thing about just holding the needle driver, well, it's not only a step that carries time, that has a dimension of effort, that has a dimension of ergonomic stress, strain, mental workload. As you could see before, this is, holding the needle driver might mean repeating that step more than once. And all that adds to the total weight of what having a step means. It's not just saying we saved one step or added one step. And of course, there's also risk attached to that. So when you include the surgeon, then you have this surgeon-driven development. And of course, when I say surgeon, I also mean end users in any other aspect of medical device development. And it's that you understand the process by understanding how the surgeon undergoes that process, how it interacts with the technology, how it interacts with all the surgical substrates and all the anatomical regions, and that creates certain challenges. And that means that a simple procedure like suturing can be broken down in many different steps and skill sets that you need to have in order to complete that in a very efficient fashion. And other devices have brought on things like maneuverability or knot tying ability, but what the driver role, as you're going to see soon, brings this third dimension of having a lot of ease of use because it capitalizes on all the training that we have as surgeons. And that means you have a short learning curve, which is very good, which also means having less needle handling time and a lot of versatility in terms of how you can use the platform in different ways. So this became a change from just a device to a system. We have the initial process of invention in which we came up with this roller system to try to maximize the fluidity of the suturing act. And then we took that initial concept and we had our end users experience that concept and morph that concept through an interface into a device that was fully functional and that delivered all the functional benefits that they wanted out of that, because it was completely guided by that end user. Not just, we didn't feed a design, we fed them the concept and they morphed that into a very clinically coherent design. And because of that interaction, not only did we develop a device, but we had an epiphany moment and we developed a system. Because you're going to see that that reinvention process led to the device, to the design of a system, not just a device. So here it is, the basic concept that for us is extremely important. For 150 years, we have had the normal incarnation of the natural needle driver, which is you have a curved needle that is grabbed by flat tips at the normal needle driver stage. And that means that you have to thread your wrist, and even if you have the robot, it's the same thing. There's a static relationship between the device and the needle. And that means that you have to drive the needle through the tissues, let go of that needle, then regrab the needle further back, and then do it again. And the same thing happens when you're retrieving that needle from the tissue. That means you have the needle, and then you have to pull it, and sometimes you cause some trauma to the tissue because the relationship is static. Whereas what we did is by changing the flat tips to rollers, we created a completely new and dynamic fluid relationship between the needle and the needle driver. And that nature of design change led to something that can allow a very continuous motion, devices a way to drive the needle fluidly through the tissues without the need to regrasp, release and regrasp. And the same thing happens when you're grabbing that needle at the other side of the tissue. But not only that, what it allows us to do by the virtue of this design, as you can see on the video that's looping on the lower side, is that it allows us to have the opportunity to drive the needle on multiple planes, which is something that is extremely important because it bestows a lot of maneuverability to a device and actually the factor articulation. And you can self-correct the needle. That decreases the amount of steps that you have in the suturing process, particularly in hard-to-reach spaces, particularly in 2D laparoscopy where you don't have a lot of depth perception. And each thing that you do decreases the amount of effort that you have to put into to basically have a very efficient suturing process. Okay? We fed that through the interfaces just to see that we had different interfaces designed and the end users waited on those interfaces, saw what works, what didn't work, until we reach an interface that basically could include all those functional benefits in a very intuitive way. And we were able to achieve that. But not only that, we were able to achieve much more, many other benefits that we at first did not think we have, and we realized that we had because of the interaction with our end users. Our end users basically could see that we had the opportunity to approach the tissue without having the needle exposed, because you could roll it at will. And then when you oppose the needle driver to the tissues, then you can roll the entire needle through in a safer way without having to carry that needle completely exposed. Also, you could have less needle handling steps overall, and you could revert that rotational motion, so you can have forehand suturing, backhand suturing, revert the stitch if you want to. You can use it for left-handed surgeons, right-handed surgeons. And it was great because one of the great things that we discovered was it was not only good for driving the needle through, isolating that motion, but also for retrieving that needle from the tissue without the use of a grasper. So in fact, we developed a one-handed suturing system that could grab the needle and getting out of the tissue, and by just pulling on that trigger, you could also roll the needle out of the tissue, and in the same step, positioning with the arc of the needle already placed for optimal needle suturing in the next suturing cycle. So you do 2 steps in one. By the fact that you have also needles that you could put in different dimensions, you also were able to highlight one quality, which is that the needles were not optimized. The current needles were not optimized for the rollers. They had been optimized for flat tip needle drivers. And that led us to design our proprietary needles, which immediately increased the versatility of the device, because that meant that you could put the needles in many, many other angles that the surgeons actually like to have a lot of versatility in hard to reach spaces. And that meant that we had now morphed from having just one device to having one system, to the point that because we could have all these needles, in different angles, we had bestowed the device with the capability to have de facto articulation on its tip without the need to incur in the cost or the complexity that having an articulated tip, would add to the device. So we're adding our value proposition to the device without increasing the complexity or the cost. And when you combine, this natural motion of the human wrist and this rolling mechanism, you can penetrate the tissues in any direction that the surgeon chooses, which is very, very, very attractive. And after saying all of this, I just wanted to show how this looks. This is our device. This is the afterthought and of all this re-engineering process of changing those fundamental relationships between the needle and the needle driver. And as you can see, this is a device that looks very familiar. It was made to look, work, and feel like a regular needle driver, but with greater capabilities. And it is very intuitive. If you can see the switch that you have in the middle to go from one point to the other, meaning that you can very quickly change the direction of the rollers. It has this Castro Viejo mechanism. Everything that you would find on a regular needle driver, plus you can see the skirts covering the rollers to decrease or eliminate the possibility of tissue getting into the rollers, and that multi-planar needle driving that you can see right then and there. And without further ado, look at this. Please look how that needle only has its tip exposed, no wrist twerking, and how that goes through the tissues, okay? You release it, no grasper needed, grab it, and then pull on the trigger. That immediately rolls it out and position it, in a very good position for the next suturing cycle, and then you just go back and repeat exactly the same thing. The more times that you do it, the more time that you save, because everything that you're doing is just optimizing the efficiency and minimizing the steps for each suturing cycle that you go into. Okay? Let's go next. So we have talked about a couple of things that the drive and roll has been able to achieve, which is decrease the needle handling time and steps and effort, during the suturing process, and also to have a very short learning curve because it is very familiar. It was designed to work as a regular needle driver should you want to do that. But now we also have the capability of making this a very versatile design. And we can do that by virtue of doing this device system very modular. You can have a reusable handle, and that handle is combined with detachable shafts, and those shafts can come in different lengths for open surgery, laparoscopic surgery, or bariatric surgery. And we can also have the surgeon use their own needles. We're not forcing anybody to have this closed system only using our needles. They can use their own needles with their own specifications, the needles that they have always used if they want to, but if they want to maximize the capabilities of the device and the versatility that they have to drive the needle in multiple planes, or to load the device with the needle, from the point of insertion through the port. They can do that because we have designed a system that can allow you to have these proprietary needles and these proprietary suture threads that can do that. So at all the steps during the suturing process, we have added features in the system that increase the efficiency of the suturing act by decreasing the amount of steps and the amount of effort and repeatability that you would find on the normal current suturing process. Okay, and I made this. We made this presentation brief. Thank you very much to all for your attention, and I would just like to finish with the quotes from our scientific advisors that you can see. One thing I would like to highlight is that we are very proud of the system that we have developed. And to the point that we have been able to garner interest from surgeons, not only to see us as a potential tool for their usage, but also they have become firm believers into our technology to the point that they have become also our investors too. And that's a great testimony to what they see and the potential that they see in our device. So I'm more than open to any kind of questions that you may have. And if not, thank you very much for your attention.
Thank you again, Luis. And yeah, if there's any questions for, if there's any questions for Claude and Luis, let me know. The team is available via email and their contact information. I can share that. Claude, one of the other co-founders, will be taking part in our panel discussion later this afternoon as well. So it is quite a great innovative product that they have been developing for some time. And we do have a question for you, Dr. Louis.
Yes.
And it's from Mr. Roy Wallen. He said, design is important, and your perspective in creating this product is an obvious advantage. There is more required to take this to the market. How are you addressing regulatory, reimbursement, marketing, sales, etc.?
Yes, of course. One of the first things that we did is that we designed these to, like I said, look and feel and work like a regular needle driver. So the regulatory pathway for us in the work that we have done seems to be pointing that this would be a class 1 510K exempt device. And that means that is taken care of. We have, of course, a business plan that entails all the business aspects of it, like the launching, marketing, sales, and everything. And of course, we're also dealing with the reimbursement aspect, which is part of the further development into the project, not the device, but capitalizing this to take this to the market. Yes, we're taking care of that.
Awesome, wonderful. And yeah, like I said, if there's any other questions for Luis and his co-founder, Claude, you can shoot me an email and I can connect you with them. But thanks again, Luis, for your wonderful presentation.